Hello everyone, very warm welcome to Venkatvarma Chemistry YouTube channel. I am Venkatvarma, your chemistry host and enthusiast. We are here to make JEE NEET chemistry preparation easier and more effective and easy to understand videos, tips and tricks to ace your exam. In this session, we are going to learn atomic structure complete in one shot revision. Atomic structure. Yes, it is complete. The atomic structure completely formula based topic. So we can start our topic atomic structure. See, let's begin our session. In the first concept is electromagnetic radiations. What it means electromagnetic radiation? See, the arrangement of different radiations, increasing of the wavelength or decreasing of the frequency with equal velocity is the electromagnetic radiation. What is electromagnetic radiation? The arrangement of different radiation in the increasing order of the wavelength or decreasing order of frequency with equal velocities is called as electromagnetic radiation, in short EMR. So what are the electromagnetic radiation? See, the first one is cosmic rays. See, cosmic rays and gamma rays, X-rays and UV and visible radiation and IR radiation, microwave and radio wave. These are the electromagnetic radiation. See, cosmic rays, gamma rays, X-rays, UV, visible, IR, microwave and radio waves. In this electromagnetic radiation, lambda will be increases when most left to right. Wavelength is increases when left to right. We moves left to right. See, frequency will decreases when moves right to left. See, wavelength is increases left to right. Frequency moves to right to left. So left to right. See, how to remember this electromagnetic radiation? See, cosmic rays. See, classical, gamma, Gaudi, X, UV, classical Gaudi, X, UV in my range. This is a way to remember order of electromagnetic radiation. See, now we can move. This visible radiation, it is a range is 380 nm to 760 nm. So we can move. See, what is a visible radiation? Visible radiation is a 360. See, visible radiation is a 380 nanometer to 760 nanometer or 3000 angstroms to 7600 angstroms. This is the range of visible radiation. That is a WBJEE. What is that? That is a WBJEE. WBJEE. Yes. Now, what are the properties of electromagnetic radiation? The first one is the property. What is a property? And their formula and their units. Yes. What is the property? Wavelength. Wavelength, it is a lambda equal to c by nu. Lambda equal to c by nu. C is the velocity of light, nu is the frequency. Its units: angstroms, nanometers, picometers. Yes, these are the units of wavelength. See, 1 angstrom equal to 10 power minus 10 meters. Okay, 1 nanometer equal to 10 power minus 9 meters. Yes, 1 pm equal to 10 power minus 12 meters. 10 power minus 12 meter. 1 fm equal to 1 fem equal to 10 power minus 15 meters. These are the important units. Okay, next coming to nu. Nu is the frequency. Frequency nu equal to c by lambda. So its units hertz or CPS, cycle per second. So nu bar. So it is a wave number. Wave number nu bar equal to 1 by lambda. So it is centimeter inverse or meter inverse. Centimeter inverse or meter inverse. Now C equal to velocity. C equal to nu into lambda. Generally nu bar equal to nu by C. Yes. Now what are the velocity units? So meter per second. Meter per second is the units of velocity. Yes. See. Have a look for electromagnetic radiation. See, cosmic, gamma, X-ray, UV, visible, IR, micro, and radio waves. Yes. See, I am writing the radiation which has maximum wavelength. So, UV is there, radio is there, X-ray is there, IR is there, which has maximum lambda, which has maximum wavelength is a radio waves. From left to right, their wavelength is increases. Yes, electromagnetic radiation, which of the following has greater wavelength than visible radiation? So greater radiation, see, electromagnetic radiation, greater wavelength, greater lambda than visible light. So UV is there. Okay, IR, gamma, X-ray, gamma. So gamma, X-ray, UV. These are lesser, which is higher. IR is a greater than wavelength of visible light or visible radiation. See, next move. So if lambda of particular wavelength is 5000 angstroms, calculate the nu. Nu means frequency. See here, what is given? Lambda is given. Lambda is given. How much is given lambda? Lambda is equal to 5000 angstroms. 5000 angstroms means it is what? 5000 into 1 angstrom equal to how many meters? 10 power minus meters. Yes, this can be written as 5 into 10 power minus 7 meters. Yes, this is the lambda. What is the c? C is the velocity of light. It is the 3 into 10 power 8 meter per second. So now we can calculate what? We can calculate it nu equal to c by lambda. Yes, c is there, lambda is there. What is the c value? C value equal to 3 into 10 power 8 meter per second. What is the lambda? Lambda is the 5 into 10 power minus 7 meters. Meter cancel. So we are getting 3 by 5 means it is a 0.6 into 10 power 15. 10 power 15 seconds. Yes, or hedges. So, second inverse are hedges. Yes. Let's move on. Next. Calculate nu bar means wave number in centimeter or frequency of yellow radiation having the lambda of 5800 angstrom. 5800 angstrom. Yes. See what we can find nu bar and nu. First of all, write the given value. So lambda is given 5800 angstroms. We can calculate it 5800 into 10 power minus 8 centimeter. Yes, this can be written as or 5800 into 10 power minus 10 meters. Yes, yes. Now, what is a nu bar? Nu bar equal to 1 upon lambda. So 1 upon lambda equal to 5800 into 10 power minus 10. Yes, it becomes the value is 1.724 into 10 power 6 meter inverse, or this can be written as 1.724 into 10 power 4 centimeter inverse, meter inverse, centimeter inverse. Yes, what next? Next we can calculate what? Nu. Nu equal to C by lambda. What is the C value? 3 into 10 power 8 meter per second. What is the lambda? Already we have calculated lambda. So 5800 into 10 power minus 10 meters. What is the value for? What is the value for nu? What is the value for nu? See, that value is 5.12 into 10 power 14 second inverse. Second inverse. Yes, this is the frequency. This is the frequency. I will look for next. Which of the has highest frequency? Which of the following is highest frequency? See, which has highest frequency? Which has highest frequency? They are giving gamma, yellow, infra, radio waves. Which has highest? So gamma has highest frequency. Gamma has highest frequency. Yes. Next, have a look for Planck's quantum theory. Planck's quantum theory. What is Planck quantum theory? See, the energy of quantum radiation. The energy of quantum radiation is directly proportional to frequency of radiation. See, the energy of quantum radiation. See, the energy of quantum radiation. Quantum radiation is directly proportional to frequency of radiation. Frequency of radiation. Frequency of radiation. That is, E is directly proportional to nu. E is directly proportional to nu. So E means energy of radiation. Nu means frequency of. See, generally E is directly proportional to nu. So E equal to h nu. Equal to h nu. What is h? H equal to Planck's constant. H equal to Planck's constant. What it values? It value equal to 6.626 into 10 power minus 27 erg per second, or 6.626 into 10 power minus 34 joules per second, or H equal to 3.66 into 10 power minus 13 kilojoules per second per mole. This is the Planck's constant values in different units. See, so E equal to h nu. E equal to h nu. What is a nu? Nu equal to C by lambda. Nu equal to C by lambda. So what is equal to? E equal to hc by lambda. Equal to hc by lambda. Yes. Now E equal to hc by lambda. What it means? Energy emitted or observed is a simple multiple of quantum. Energy is emitted energy or observed energy is simple multiple of quantum, but not fractional values. It is equal to E equal to nh nu. Equal to nh nu. What? Energy of emitted or observed radiation is multiple of quantum but not fraction value. So this can be written as E equal to nhc by lambda. nhc by lambda. Yes. Now E equal to, we can substitute the Planck constant H value and C value, velocity of light. Here becomes the standard values 1240 lambda in angstroms. Remember this, E equal to N into 1240 or 1240 by lambda in angstroms, or 1240 lambda in nanometer, remember this standard value. This value we can use problems. Okay, so right, what is a 1 electrovolt? 1 electrovolt equal to 1.6 into 10 power minus 19 joules. 1 electrovolt equal to 1.6 into 10 power minus 19 joules. What is a Na? So what is a Na? See, I will look for energy carried by 1 mole of photon. 1 mole of photon is called as Einstein. Yes, this can be written as E equal to NaH nu. What is the N? N equal to Avogadro number. Its value equal to 6.023 into 10 power 23. Energy carried by 1 mole of photon is called as Einstein. It is equal to E equal to NaH nu. So first of all, E equal to, so what is Na? Avogadro number 6.023 into 10 power 23. What is the H is a Planck's constant. It is a 6.62 into 10 power minus 34. Yes, and this is the value H nu. E equal to NaH into nu. Yes. Now, what is a nu? Nu is the frequency of radiation. Have a look for question. Calculate the energy of 1 mole of quanta of radiation whose frequency is 5 into 10 power 10 second inverse. So what we can calculate it? We can calculate radiation. Energy of radiation. See, what is the energy of radiation? E equal to NaH nu. Yes, E equal to, what is Na? Na is a 6.023 into 10 power 23. What is the H? H is a Planck constant. It is a 6.62 into minus 34 into, what is the nu? Nu is they are giving, it is a 5 into 10 power 10 second inverse. So multiplied these values, we are getting 19.95 joule mole inverse. Yes, this is the energy of radiation. Now coming to next one, energy of, see, just a bulb emit light of wavelength is 4500 angstrom. The bulb is rated as 150 watt and 8% of energy is emitted. And light, how many photons are emitted by a bulb per second? Yes, what is the, write the, what is the lambda? What is the lambda value? 4500 angstroms. Yes, lambda is given. What next given? See, power is given. Power. What is the power? Power equal to energy per second. Energy per second. Power means energy per second. How much energy? It is a 150 watt. 150 watt. It is equal to 150 joules energy. Yes, energy equal to power into time. Yes, power into time. Yes, now what is energy emitted? See, energy emitted equal to, energy emitted, it is equal to 150. What is the percentage? 8. 8 by 100. This much of percentage is energy emitted light. It is equal to how much? It becomes 12 joules. It becomes 12 joules. Yes. Now we can calculate radiant energy. We can calculate radiant energy. It is equal to, what is the principle? E equal to NHC by lambda. Yes. What is the in value? What is the in value? It is equal to 12 joules. What is the H? What is the H? H equal to 6.626 into 10 power minus 34. Yes. What is the velocity? 3 into 10 power 8. So hc by lambda. So I am writing hc by lambda n into. So but we want what? N. Sorry, energy of emitted is a 12 joules. Energy of emitted is a 12 joule. We can calculate it as a in value. N equal to, what is the energy of emitted? It is a 12. Yes. What is the lambda? 4,500 angstroms. Yes. What is the 10 power minus 10 meters? Yes. Divided by H. H is the 6.6 into 10 power minus 34. What is the light? C equal to 10 power 8. Yes. We can multiply and divide it by these values. We are getting 2.727 into 10 power 17 photons. 17 photons. Yes. Coming to next problem. Energy of photon whose wavelength is 310 nanometers. See, energy of photon whose value is 310 nanometers. See, for example, E equal to N hc by lambda. What is the 1240 divided by lambda in angstroms? It is a standard value. Yes. Now we can write E equal to 1 into 1240. Lambda means 310 nanometer. It is equal to 3100 angstroms. Yes. It is 3100 angstroms. We are getting what? 4 electrovolt. What is the 1 electrovolt? 1 electrovolt equal to 1.6 into 10 power minus 19 joules. 4 volts means it is equal to energy equal to 4 into 1.6 into 10 power minus 19 joules. This is the value. Yes. Now coming to next concept, third concept. See, photoelectric effect. Photoelectric effect. See, what is photoelectric effect? See, the ejection of electrons. See, the ejection of electron from metal surface when incident of light frequency in the suitable surface, it eject the electron from metal surface. That electrons are photoelectron. The phenomenon is known as photoelectric effect. Ejection of electron from surface of metal when light in suitable frequency strikes is called as photoelectric effect. So photoelectric effect exhibited like potassium, rubidium, cesium metal. Yes. So it is equal to incident light EI equal to energy to electron comes from the metal surface plus energy to move the electron. So EI, incident of light EI equal to pi into kinetic energy is maximum. Kinetic energy is the maximum. Yes. Now coming to photoelectric effect. See, if photoelectric effect, this can be written as EI equal to pi plus kinetic energy is the max. Yes. Now AI, it is equal to h nu, pi equal to h nu naught plus kinetic energy maximum is of mv square max. Yes. Now what is the m? M is the mass of electron. M is the mass of electron. What is the nu? Nu is the incident light frequency. Incident light frequency. Incident light frequency. Yes. What is a nu naught? Nu naught equal to threshold frequency. Nu naught equal to threshold frequency. Nu naught equal to threshold frequency. Yes. Now, h nu equal to h nu naught plus half mu square. Yes. So this can be written as, so Ke max equal to h nu minus h nu naught, h nu minus h nu naught, Ke equal to. So this can be written as Ke equal to, what is a nu? Nu equal to C by lambda. So Hc by lambda minus Hc by lambda naught, Hc by lambda naught. Yes. Now this can be written as, Ke equal to Hc 1 upon lambda minus 1 upon lambda naught. Yes. This is the equation to calculate kinetic energy in photoelectric effect. Yes. Now see, important point, photoelectric effect. Photoelectric effect is the number of photoelectrons emitted is directly proportional to intensity of incident light. So it is equal to number of photoelectrons is directly proportional to intensity of light. Yes. Now have a look for graphs. See. The graphs is the kinetic energy versus intensity of radiation. See, Ke versus intensity of radiation, its kinetic energy equal to constant. Ke equal to constant. Yes. Now, kinetic energy versus frequency. It is x-axis, it is y-axis. It becomes, see, I am writing energy of intensity radiation equal to pi plus kinetic energy. Yes, it is equal to h nu naught plus Ke kinetic energy. So K equal to what? K equal to h nu minus h nu naught. Now Ke is inversely proportional to mu naught. Yes, it is a K. The graph is, slope becomes h. Now the graph plotted between Ke versus nu minus nu naught. See, here energy of radiation, incident radiation equal to pi into Ke. Yes. So it is Ke equal to what? H nu minus nu naught. Here slope equal to h. Yes. Now see, when photoelectric effect, then photoelectric effect is observed only nu is greater than nu naught. it is observed. Nu is less than nu naught. Not observed the no photoelectric effect. It is the photoelectric effect is observed. Next, nu equal to nu naught. Here also photoelectric effect is observed, but kinetic energy equal to 0. Ke equal to 0. Kinetic energy equal to 0. Yes, now have a look for problem. Calculate kinetic energy of electron emitted when radiation of frequency is 1.1 into 10 power 15 second inverse. Hit the metal, nu naught equal to 6 into 10 power 14 second inverse. They are giving nu naught. What is the value of nu naught? 6 into 10 power 14 second inverse. Yes. Now what is the principle? So HNU equal to HNU naught plus K. Kinetic energy is maximum. Now H. What is a nu? Nu equal to 1.1 into 10 power 15. Now what is H? Next H. What is nu naught? 6 into 10 power 14. See, plus kinetic energy K E kinetic energy. Yes. Now this can be written as see 1 into 10 power 14. Yes, H into 6 into 10 power 14 plus kinetic energy. Now Ke equal to 5 into H into 10 power 14. Yes. Now it is equal to 5 into what is a H 6.6 into minus 34 into 10 power 14. We are getting 5 into 6.6 into 10 power minus 20 joules. This is the key kinetic energy of maximum. Have a look for next problem. Calculate the kinetic energy of electron ejected when light of wavelength 4 into 10 power minus 7 meter fall on the surface of metal. The threshold wavelength of metal is 8 into 10 power 7 meters. See. So, first what is given? See, first energy of photon. See, energy of photon equal to hc by lambda, E equal to hc by lambda. So hc by lambda equal to hc by lambda naught plus kinetic energy. Yes, now Ke equal to what? Ke equal to hc by lambda minus hc by lambda naught. Yes, now hc equal to 1 upon lambda minus 1 upon lambda naught. Yes. Now hc equal to 1 upon lambda. What is the lambda value? 4 into 10 power minus 17. What is the lambda naught value? It is the 8 into 10 power minus 7. Yes. Now we can calculate this value. Here becomes, what is the value? It becomes 6.6 into 10 power minus 34 into, what is the value? 3 into 10 power 8, 3 into 10 power 8 into 1 upon 8 into 10 power minus 7. Yes, it becomes 2.4 into 10 power minus 19 joules. Yes, this is the value. Look for this problem. See, the number of metals which shows photoelectric effect when light of 310 nanometer wavelength fall on the metal. Which of the lithium, sodium, potassium, magnesium, copper, silver, iron, platinum. They are giving different types of values. How to calculate? So energy of incident radiation equal to 1240 divided by lambda in angstroms. Lambda in angstroms. It is equal to 1240. Lambda is nanometer is given. It becomes 3100 angstroms. It becomes what? 4. It is a 4 electrovolt. So lambda equal to 310 nanometer. It becomes 3100 angstroms. It becomes 4 electrovolts. So number of metals we can choose below the value. 4 electrovolt. What is the below values? Below values 3.7, 2.2, 2.3, 2.4. How many number of metals? How many number of metals are present below this value? They are 4. Magnesium, potassium, lithium, sodium. Number of metals equal to magnesium, potassium, sodium, lithium. So 4. Yes. Now coming to next concept. Next concept is Bohr's atomic model. In the Bohr's atomic model, it is applicable for one electron system. Very important point. It is applicable one electron system like what are the one electron? Hydrogen, helium plus, lithium 2 plus, beryllium 3 plus, like that. Applicable these elements. Yes. What is the orbital angular momentum of electron? See, orbital angular momentum of electron, angular momentum of electron, orbital angular momentum of electron equal to what? mvr. What is mvr? See, mvr equal to nh by 2 pi, nh by 2 pi. See, it is equal to mvr equal to, so h cross equal to nh by 2 pi. H cross, it is equal to n h cross. mvr equal to n h cross. Yes. Now coming to radius. See, coming to radius. See, radius r equal to r naught into n square by z. N square by z. It is also known as a naught into n square by z. Yes. So it is equal to 0.53 into n square by z. This is about radius principle r. Yes. So r naught equal to a naught. It is a Bohr radius. It is a Bohr radius. The Bohr radius equal to 0.53. 0.53 angstroms. 0.53 angstroms. Yes. If different radiations R1 upon R2 equal to N1 square upon N2 square into Z2 by Z1. What is a Z? Z equal to atomic number. Z equal to atomic number. Yes. What is R1, R2? R1, R2 is a radius of two different orbitals. Z1, Z2 different atomic number. Yes. N1, N2, it is a principal quantum number. It is a principal quantum number. Next, coming to next one. See, number of revolution. See, number of revolutions by the electron. Number of revolution by the electron in 1 second. In 1 second, it is equal to v upon 2 pi r. Yes, v equal to what? Velocity. 2 pi r means circumference of Bohr orbit. 2 pi r is the circumference of Bohr orbit. Bohr. Next, coming to velocity of electron. See, next is the velocity of electron. Velocity of electron, it is equal to what? 2.18 into 10 power 6 into Z by N meter per second. Meter per second. It is a velocity of light. So Vn equal to Z by N. Yes, it is also known as V1 by V2 equal to N2 by N1 into Z1 upon Z2. So different velocity of electron principle we can calculate V1 by V2 equal to N2 by N1 into Z2 by Z1. Yes, next coming to next principle, see time period. Next is the time period. What is the time period? It is equal to T is inversely proportional to N cube and directly proportional to Z. Directly proportional to Z square. Directly proportional to Z square. Time period. Next coming to frequency. Frequency F equal to 1 by T. Frequency F equal to 1 by T. So F is directly proportional to Z square and inversely proportional to N cube. N cube. Next coming to energy of electron. Total energy of electron. See, next is the total energy of electron. Total energy of electron. Total energy of electron equal to minus 13.6 into Z square by N square electrovolt per atom. Electrovolt per atom. Yes. Total energy equal to minus 13.6 into Z square by N square electrovolts. Next, total energy equal to minus kinetic energy equal to potential energy by 2. Total energy equal to minus kinetic energy equal to potential energy by 2. So now ionization energy equal to plus 13.6 into Z square electrovolt per atom. Ionization energy equal to plus 13.6 into Z square electrovolt per atom. Next coming to C. Excitation energy. Excitation energy equal to 13.6 into Z square into 1 upon 1 minus 1 upon N square electrovolt per atom. Electrovolt per atom. It is the excitation energy. Excitation energy 13.6 into Z square into 1 minus 1 upon N square electrovolt per atom. Next coming to next principle. See, binding energy B equal to plus 13.6 into N square by Z square by N square is equal to plus 13.6 into Z square by N square electrovolt per atom. Electrovolt per atom. So B equal to IE upon N square. B equal to IE upon N square. See, what is mean excitation state? See, for example, third excited state. What it n value? So n value equal to 4. If fourth excited state, its n value what? 5. Yes. Now coming to next principle. See, the next concept, hydrogen spectrum. What is hydrogen spectrum? See, by applying high potential difference in electrical discharge tube containing hydrogen gas, a bright line is obtained. This light is when passing through prism, immersed beam of light is collected over photographic plate is known as hydrogen spectrum. So these radiations are observed in different series in different lines. They are Lyman series, Balmer series, Passion series, Bracket, Fund and Humry series. Yes, different Lyman series it is present in UV region. Yes, Bracket series it is present in visible region, and Passion series it is present in near IR. Bracket is a middle IR. P fund is a far IR. Yes, these are having different radiation. So if energy En equal to minus 1312 upon n square. What is the energy? Energy N1 equal to Lyman series equal to N equal to 1. N equal to 1 means it is equal to 1 square. It becomes 1312 kilojoules. If En equal to minus N equal to 2 means it is 2 square. It becomes what? Minus 328 kilojoules per mole. This is a way to calculate. Energy. Okay. Next coming to see. Remember these words, similar words. The first line means starting line or initial line. Lambda max and nu is the minimum. Lambda has maximum, nu has minimum. Last line, limiting line or marginal line, it is a lambda is a minimum, nu is a maximum. First line of any series means alpha. Second line of any series it is a beta. Third line of any series it is equal to gamma. Remember these similar words. Okay. See, coming to calculate radius, velocity, total energy, kinetic energy, potential energy of helium plus in first excited state. See, first of all, what is the first excited state? Its in value equal to what? 2. Z means equal to 2, atomic number 2, helium atomic number 2. So now first radius R equal to what? R naught into n square by Z. Yes, what is a R naught into n square means 2 square. Yes, upon Z equal to 2, it becomes what? 2 R naught. Yes, R 2 R naught means it is equal to R naught equal to 2 into 0.53 angstroms. Yes, now coming to velocity. V equal to 2.1 into 10 power 6 into Z by N. It is equal to 2.18 into 10 power 6. Z equal to 2, N equal to 2. It becomes 2.18 into 10 power 6 meter per second. Have a look for total energy. It is equal to minus 13.6 into Z square by N. It becomes minus 36 into Z square means 2 square upon 2 square. Sorry, it is equal to minus 13.6 electrovolt. Yes. Next, kinetic energy. Kinetic energy equal to what is? It is equal to plus 13.6 electrovolt per atom. Yes. It means minus kinetic energy equal to potential energy by 2. Now coming to potential energy. See, now coming to potential energy. Potential energy. So it is equal to what? Minus kinetic energy equal to potential energy by 2. See, potential energy equal to what? Minus 13.6 into 2. It becomes 27.2 electrovolt per atom. Yes, this is a way to calculate potential energy, kinetic energy, their total energy and their radius. Coming to next problem. calculate angular momentum of fifth orbit. What is angular momentum? mv equal to nh by 2 pi. So what is a n here? N equal to mv equal to 5h by 2 pi. It is equal to mv equal to 5 by 2. It is equal to 2.5 h by pi. Yes. Now coming to say calculate lambda of photon when electron make transition from n equal to 2 to n equal to 1. Before that, how to calculate? See how to calculate their wave number. See, for example, what is the Rydberg formula? What is the Rydberg formula? It is equal to 1 upon lambda equal to RH Z square 1 upon N1 square minus N1 square minus 1 upon N2 square. This is the formula to calculate. See, RH is the Rydberg constant. Its value equal to 109677 centimeter inverse. RH equal to 109677 centimeter inverse. Yes. Now, how to calculate total number of spectral lines during electron, total number of spectral lines during electron equal to delta n into delta n plus 1 by 2, total number of spectral lines. So what is delta n? Delta n equal to n2 minus n1. n2 is a higher energy level, n1 is a lower energy level. Next, total number of spectral lines particular series, it is equal to n2 minus n1. It is equal to n2 minus n1. See, I will look for calculate lambda of wavelength of photon when electron makes transition from n equal to 2 and n equal to 1. See, 1 upon, what is a solution? 1 upon lambda equal to RH Z square 1 upon N1 square 1 to N2 square. See, right. 1 upon lambda RH. What is the Z value? Z value of hydrogen, it is equal to 1 square. 1 upon n equal to 2, n equal to 1. So n1 square, it is equal to 1 square. See, n2 square, it is equal to 2 square. It becomes what? 1 upon lambda equal to RH 1 upon 2 square means 4. Yes, it becomes 1 by lambda equal to RH 1 upon, see, 1 minus 1 upon 1 minus 1 upon 4. See, it becomes what? 1 upon lambda equal to RH, it is equal to 3 by 4. Now lambda equal to what? 4 upon 3 RH. Lambda equal to 4 upon 3 RH. Yes, this is a value. Is the n1 equal to 1, z equal to 1, n2 equal to 2. I will look for next problem. Calculate lambda for second line of Balmer series of helium atom. Second line. For example, what is a n1 equal to what? 2. See, why it is Balmer series? Okay. n2 equal to what? Second line of Balmer series. Second line of Balmer series, it is nt equal to what? 4. What is a Z? Z is a helium atom. It is equal to 2. Yes. So they are 1 upon lambda equal to RH Z square 1 upon N1 square means 2 square, into square means 4 square. Yes, now it is equal to, see, RH, Z square means 2 square, 1 upon 4, 1 upon 16. Yes, 1 upon lambda. See, 1 upon lambda equal to RH. So 2 square means 4. So it is equal to 1 by 4 minus 1 by 6. It becomes, see, 1 by 4 means 1 minus 1 by 4. Yes, it becomes what? 1 upon lambda equal to RH. It is equal to 3 by 4. 3 by 4. Yes, 3 by 4. Next, what happened? RH into 1 upon. It becomes 1 by lambda RH equal to 3 by 4. Now, lambda equal to what? 4 by 3 RH. 4 by 3 RH. Yes. Coming to next problem. Calculate series limit Lyman series for Li plus 2. Lithium plus 2. So, lithium it is equal to Z equal to 3. Lyman series N1 equal to 1. Yes. N2 equal to what? Calculate limit. Limit means it is a infinity. So infinity means, so N1 equal to 1, N2 equal to infinity. So 1 upon lambda equal to RH Z square 1 upon N1 1 square 1 square into equal to infinity square. So what is the value? 1 upon lambda equal to RH. What is a Z? Z equal to, say, 3 square. So it is 1 upon 1 square, 1 upon infinity square. It is equal to 1 upon lambda equal to RH. Yes, 3 square means 9. Yes, it is whole term equal to 0. So now lambda equal to 1 upon 9 RH. 9 RH. Yes. Next, coming to next problem. Calculate lambda maximum, lambda minimum for Lyman series of hydrogen atom. Lambda maximum, lambda minimum for Lyman series. First of all, what is N1? N1 equal to 1. What is a Z? Z equal to 1. What is a N2? What is a N2? N2 equal to 2. N2 equal to 2. Now substitute 1 upon lambda max. Yes, it is equal to RH. What is a Z? Z equal to 1 square upon 1 square minus lambda max means it's N1 equal to 1. So N2 equal to what? N2 equal to, it is a infinity hydrogen atom. So lambda max means first line. Yes, lambda minimum means it is a last line. Last line means it is equal to infinity. It is equal to infinity. Yes, infinity. It becomes what? 1 upon lambda max equal to RH or H. Now coming to 1 upon lambda max equal to RH Z. See, Z square. For hydrogen atom, Z equal to 1. 1 upon 1 square, 1 upon 2 square. Yes. Now coming to 1 upon lambda max equal to RH into 1. 1 upon 1, 1 upon 4. Yes. It becomes 1 upon lambda max equal to RH 3 by 4. 3 by 4. It becomes lambda equal to 4 upon 3 RH. 4 upon 3 RH. So, first line, last line. First line means alpha. Last line. Last line means lambda minimum. Lambda minimum. Yes. Now we can move to next. Just find the spectral lines in Balmer series when electron makes transition from 14th excited state to ground state. See, spectral lines equal to what? Spectral lines equal to in Balmer series. In Balmer series, it is N1 equal to 2 Balmer series. So N2 equal to makes transition from 14th excited state. 14th excited state means N2 equal to 15. N2 equal to 15. It makes what? N2 minus N1. So spectral line in Balmer series N2 minus N1. N2 minus N2 equal to what? 15. N1 equal to 2. It is equal to 15 minus 2. It is equal to 13. It is equal to 13. Yes. Next. See, find out total number of spectral line which electron makes from ninth excited state to first excited state. First of all, we can calculate what is a N1 value. Ninth excited state means it is becomes 10, and N2 equal to first excited state. First excited state means N2 equal to 2. What is the delta N? Delta N equal to N2 minus N1. N2 equal to what is a N2? N2 equal to 10. Sorry. N2 equal to 10, N1 equal to 2, N1 equal to 2. Yes, it is equal to 10 minus 2. It becomes what is? It is a 8. Ninth excited state, first excited state. Yes, it is equal to N1. It is equal to N2. Yes. Now coming to what is a spectral line calculation? How to calculate number of spectral line? Delta N plus 1 by 2. See, what is the delta N? 8. Delta N plus 1, 8 plus 1 by 2. It becomes what is the value? What is the value? So it is equal to 4. 4 into 9, it is equal to 36. It is equal to 36. Yes. Now coming to next. Coming to de Broglie's hypothesis. What is de Broglie hypothesis? Any moving particle has wave character. These waves are called matter waves. Yes. This having dual character, wave nature and particle nature. Particle nature, dual nature. Wave nature and particle nature. Wave nature and particle nature. So it is a principle. What is a lambda equal to h upon m into v? It is equal to h upon p. M into v equal to p. So what is a p? P is the momentum of particle. Momentum of particle. Momentum of particle. What is the m? M is the mass of electron, or mass of particle. M is the mass of particle. Yes. Now this can be written as it is equal to lambda equal to h upon under root 2 ek into m. Ek into m. Ek is the kinetic energy of particle. Kinetic energy of particle. Kinetic energy of particle. Kinetic energy of particle. See, if lambda 1 equal to lambda 2, then v1 upon v2 equal to m2 by m1. M2 by m1. If v1 equal to v2, then lambda 1 by lambda 2 equal to m2 by m1. Yes. Next, if lambda 1 upon lambda 2 equal to m2 into v2 by m1 into V1. Yes. Now equation for ek1 upon ek2, it is equal to m2 into lambda 2 square upon m1 lambda 1 square. These are the principle to use different problems. Yes. Now this can be written as, see, lambda equal to h upon under root 2 qvm. Also q is a charge of particle, q is the charge of particle. Yes. Next, now coming to the circumference of Bohr circular orbit. See, the circumference of Bohr circular orbit, 2 pi r equal to n lambda, 2 pi r equal to n lambda. So yes, now n equal to 2 pi r by lambda, n equal to 2 pi r by lambda, n equal to number of shells, n equal to number of shell, Yes. So what is 2 pi r equal to? 2 pi r equal to n into lambda. So what is the radius? R equal to r naught into n square by z, angstroms. It is equal to 0.53 into n square by z. This is a r value. Yes. Now coming to the problem. A ball weighing 25 grams with velocity 6.6 into 10 power 4 meter per second. Find the de Broglie wavelength associated with. Yes. What is the principle used to calculate lambda? Lambda equal to h upon m into v. Yes. What is the m? What is the h? 6.6 into minus 34 joules. Yes. In eggs means 10 power 7 eggs. Mass of electron, it is a 25 grams. It is a 25 grams. What is the velocity? It is a 6.6 into 10 power 4 centimeter per second. Yes, we can solve. We are getting 0.04 into 10 power minus 31 centimeters, or 4 into 10 power minus 33 centimeter. This is a way to calculate wavelength of de Broglie waves equation. Yes. Next, coming to Heisenberg uncertainty principle. It is impossible to determine simultaneously exact position and exact momentum of or velocity of electron. It is called Heisenberg uncertainty principle. It is impossible to determine position and momentum of electron simultaneously and accurately is called as Heisenberg uncertainty principle. See, here delta x into delta p is greater than equal to h upon 4 pi. Yes. What is the delta v? Delta v is the uncertainty of velocity. Yes. Now delta x. What is delta x? Uncertainty in position. Yes. Now this can be written as m into delta v into delta x is greater than equal to h upon 4 pi. Yes. Now this can be written as delta x into delta v is greater than h upon 4 pi m. 4 pi m. Yes. Now the value of h upon 4 pi equal to 0.52 into 10 power minus 34 in SI unit. Yes, the value of h upon 4 pi m, its value equal to 0.0579 into 10 power minus 3. 10 power minus 3. See, have a look for problem. See, a golf golf ball has 40 grams and speed is of 45 meters per second. If speed can be measured with an accuracy of 2%, calculate uncertainty in position. See, they are giving mass is given. Yes or no? Mass is given. Mass how much is given? It is the 45 grams. See, now speed is 45. Mass is the 40 grams. Just wait. See, mass is the 45 grams. Yes. Now velocity is the 45 meter per second. Yes. It is delta V equal to 45 into how much measured within accuracy 2%. 2 upon 100. 2 upon 100. It becomes what? 0.9. 0.9. So what is Heisenberg uncertainty principle? Delta X into delta P is equal to h upon 4 pi. H upon 4 pi. So we can calculate h is the delta equal to h upon 4 pi into delta x. Sorry, delta b. Delta b. Yes, now we can calculate x is a 6.6 into 10 power minus 34. 4 into what is a pi value? It is a 3.14. Delta v is there. It is a 0.9. Their mass equal to 45. Their mass equal to 45. 4 pi m delta v. See, it becomes 4 into 3.4, 0.9, 45. It becomes 6.6 into minus 34 divided by, it becomes 508.68. It becomes, what is the value? 0.012 into 10 power minus 34. This is the value. Take again. Coming to next concept, quantum numbers. What are the quantum numbers? Quantum numbers is a set of numbers which explain state of electron. State of electron. It means location of electron or location of energy, type of orbital or orientation of orbital. It denotes simply address of electron in any atom to explain the quantum number. A set of 4 quantum number which explain state of electron, location of electron, type of orbital, orientation of orbital. It denotes the address of electron in any atom. So electron address equal to shell, subshell, orbital and spin. See, the first quantum number is a principal quantum number. See, have a look for principal quantum number. See, principal quantum number. It is represented by n, small n. It describes the what? It describes the shell or orbit. It describes shell or orbit or energy level. So its n value equal to 1, 2, 3, 4, etc. It is equal to K, L, M, N, etc. Now, orbital angular momentum equal to what? MVR equal to NH by 2 pi. Next, coming to total orbitals. Total orbitals are calculated by using n square. Total number of electrons. See, total number of electrons is calculated by 2n square. 2n square in nth orbit. Yes. Now coming to second one. Azimuthal quantum number. See, next is a azimuthal quantum number. So azimuthal quantum number, it is represented by small l. See, it describe the shape of subshell or suborbit or sub energy level. Yes, if L value equal to 0 to n minus 1. If L equal to 0, 1, 2, 3, 4, L equal to 0 s orbital, L equal to 1 p orbital, it is d, it is f. Yes, L equal to 0 means s orbital, L equal to 1 means p orbital, L equal to 2 means d orbital, L equal to 3 means f orbital. S, P, D, F, G orbital. Yes, now coming to next point. See, orbital angular momentum. It is equal to under root L into L plus 1 h upon 2 pi. So it is equal to under root L into L plus 1 h cross. H by 2 pi means h cross. Next point is the total orbitals. See, total orbital is calculated 2L plus 1. Yes, total electrons is calculated by 2 into 2L plus 1. See, it is a in subshell. Yes, have a look for next quantum number, magnetic quantum number. Third one, magnetic quantum number. It is represented by m small, ml. Yes, it describes the orientation of subshell. Describe the orientation of subshell. Its m value equal to minus L2 plus L values. Yes, now see, L equal to 0, possible m value plus or minus 1, 0. If L equal to 2, its m value plus or minus 2, plus or minus 1 and 0 values. Yes, now coming to spin quantum number. Fourth one, spin quantum number. It is represented by S. Or EMS. Yes, its spin either clockwise or anti-clockwise direction. Clockwise direction or anti-clockwise direction is equal to plus of or minus of. Yes, spin angular momentum equal to under root s into s plus 1 h by 2 pi. H by 2 pi. It is equal to under root s into s plus 1 h cross. Yes, if s equal to n by 2, so n equal to number of unpaired electrons. Yes. Now total spin is calculated by plus or minus n by 2. Yes. If n equal to 3, L equal to 2. What are the orbitals? So n equal to, what is a orbital? Orbital is a 3 square. Yes. 3 square means 9. If L equal to 2, what are the orbitals? So 2 into 2 L plus 1. Yes. It becomes 2 into 2 plus 1. Sorry. 2L plus 1. It becomes 2 are 2, 4 and 5. Yes. This one. Yes. Now find the subshell. Find the subshell. See, n equal to n equal to n equal to and L equal to. So n equal to 3, L equal to 0. It becomes what? 3s. N equal to 4, L equal to 1. It is a 4p. Yes. N equal to 5, L equal to 2. It is a 5d. N equal to 2, L equal to 2. What is orbital? It is a 3d. It is a 3d. Sorry, it is a 2d. Not happen. L equal to 0, 1, 2, 3. S orbital, p orbital, d orbital, f orbital. N equal to 2. N equal to 2. Yes. L equal to 2. L equal to 2 means d orbital. So 2d is not possible. 2d is a not possible. Not possible. Yes. Next. Calculate orbital angular momentum. How to calculate orbital angular momentum? Orbital angular momentum. See, it is equal to what? 2s means under root s equal to 0. So 0, 0 plus 1. It becomes what? h cross equal to 0 or h by 2 pi. H by 2 pi or h cross. So 3p. 3p. L equal to what? 1. 1 into 1 plus 1 h cross. What is the value? It is 1 plus 1 to root 2 h cross. Now coming to 4d. D equal to what is the n value? 2. 2 plus 1 h cross. 3 2 root 6 h cross. Yes, 5. F equal to what is the n value? 3. 3 plus 1 h cross. See, 4 is the 3, 12 root 12 h cross. Root 12 h cross. Yes. Now look at for important formulas. See, total nodes. Total nodes is calculated by n minus 1. Yes. Now radial or spherical nodes. Radial or spherical nodes equal to n minus L minus 1. Yes. Third one, nodal planes. Nodal planes or angular node. Angular node equal to L. Equal to L. Yes. Next, energy of subshell. Energy of subshell. Bohr-Bury rule or n plus 1 rule. proportional to N plus L. Yes, if N plus L is same, E is directly proportional to N. E is directly proportional to N. Yes, have a look for finding the total nodes, radial nodes, and angular nodes or nodal plane. For example, see n equal to 3. N equal to 3 means L equal to 0. What is a orbital? It is a 3s orbital. In 3s orbital, total number of nodes means n minus 1. N equal to 3 minus 1. It becomes how many total number of nodes? In 3s orbital, it is equal to 2. How many radial nodes? It is the total number of nodes. What is the radial nodes? N minus L minus 1. So what is the N value? 3. What is the L value? L value equal to 0 and 1. It becomes what? 2. What is the nodal planes? L equal to what? 0. L equal to what? L equal to 0. Find the next one. If n equal to 4, L equal to 1, it is equal to what? 4p. 4p. In 4p, total number of nodes n minus 1. N equal to 4. 4 minus 1. 3. Yes. And finding the radial nodes. What is the radial nodes? N minus L minus 1. N equal to 4. What is the L? 1 minus 1. It becomes what? 4 minus 1. 3 minus 1. It is equal to 2. Next, nodal planes are angular nodes. It is equal to what? L. L equal to what? 1. So this is a way to calculate total number of nodes, radial nodes. Angular nodes are nodal planes. Yes, this is a complete revision of atomic structure. I hope you like this video. Don't forget to share your friends. Don't forget to give the like. If this content is valuable, make sure to subscribe our channel, to hit the bell icons to stay updated for latest videos and notifications. Thanks for watching.